Okay, in this video I'm going to work out a normal distribution problem which is similar, I think, to number 8 on assignment number 2. Alright, in this problem we are told magnitude of earthquakes since 1900 that measure 0.1 or higher on a Richter scale in California has a normal distribution. The mean of that population of earthquakes is 6.2 with a standard deviation of 0.5. Okay, so we know we're dealing with a normal distribution. Two numbers we need to define a normal distribution are the mean and the standard deviation, and that's given to us. All right, and we have a series of questions here about probability. Now, probability, generally speaking, is area under the normal curve. I'm going to work through these problems by hand, and I think at the end of each section I'm also going to take you into Minitab and show you how Minitab does it. Now, Minitab will do it in a flash, but you really need to have some understanding of how the problems are worked out. All right, let's look at part A of this question. It asks us to find the probability that a randomly selected earthquake, okay, we pick one earthquake from a database or something. We want to know what's the probability it has a magnitude of 6.0 or higher. Now, if I scroll down on this sheet that I have here, which I am going to post, I've worked this problem out by hand. So first of all, what do I know? I know the mean of this distribution is 6.2 and it has a standard deviation of 0.5. And I've said right here in shorthand that's usually written as N in italics, which tells me I'm dealing with normal distribution. There's the mean, there's the standard deviation. Now generally when you're dealing with problems like part A here, you draw a curve. And I just whip out my pencil, pen, whatever, and draw the area of the curve that I'm looking for. Now, first of all, I know it's a normal distribution. So I've drawn this little normal curve. I know the center of this distribution, the mean of it, mu, is equal to 6.2. That's the mean of the population. Our question in part A is what's the probability the magnitude could be 6.0 or higher? So, all right. Right here, 6.0, of course, has to be below 6.2. And I'm looking for area under the curve because that's what probability represents in some aspects. All right, and mathematically, what do I want to know? I want to know what's the probability, that's that capital P, that x is a value that's greater than or equal to 6.0. Well, if I'm answering these questions by hand, I have to work out an equivalent z-score. In other words, I have to standardize the value 6.0. And in the old days before computers, you would go into the standard normal distribution tables and you would get your answer. All right, so I take this distribution, which has to do with magnitudes of earthquakes in California, and I convert the x value of 6.0 to an equivalent z-score using this formula right here. All right, x is 6.0, the mean I know is 6.2, and the standard deviation is 0.5. I work this out, I get a z-score of negative 0.4. Now, I'm redrawing my curve, but this time I'm redrawing it from the perspective of what we refer to as the standard normal distribution. And in the standard normal distribution, the center of this distribution always has a z-score of 0. Anything below will be negative, anything above will be positive. And a z-score of negative 0.4 is going to be about right here. And basically, I want to find the area to the right of it. Okay, now we go to tables, but before I get to the table, one second here, in answering my problem, I want to know what's the probability x is greater than or equal to 6. The tables that you have in your book and that I've put on D2L only show you areas to the left. They don't show you areas to the right. So just coming back up to this graphic right here, I'm going to go into my standard normal distribution tables here now in a second, and we're going to find that the area to the left of a z-score of negative 0.4 right here That area rolls out to be 0.3446. The total area under any of these curves has to always be equal to 1. How come? Because this is the distribution of all members of your population, and if you add up the probabilities of all members of your population, it has to total 100%. And rather than speaking of it in terms of percent, we talk about it in terms of a proportion. So total area under the curve is always equal to 1. All right, if I know the total area is equal to 1, and I know the area to the left of this z-score is negative 0.4, and that value is 0.3446, how do I do that mathematically? Well, right here, 1 minus the area to the left will give me the area to the right. And that means 0.6554 is the area under the curve to the right of a z-score of negative 0.4. It also represents the area to the right of an earthquake that has a magnitude of 6.0. Therefore, I can say there's a 65.54% chance that a randomly chosen earthquake in California will have a magnitude of 6.0 or higher. Now, let me go to our course home. Hang on now, I got to move my window over here. 1 second. Okay, I'm here in our course. Under the Resources tab, there's a tab here that says Statistical Tables. We want to use the normal distribution tables. All right, this table pops up. And by the way, you could print this off if you want. Anyway, in this problem, we didn't have a positive z because z worked out to be a negative 0.4. So if I scroll down, there's another table here that gives me areas to the left of a negative z. So I can see that this is kind of what it's doing here. We worked out a z-score of negative 0.4. So if I scroll down here, here's negative 0.4 right here. Don't know if it'll let me, okay, right there. Yeah, in that row right there. And if I scroll back up, here's 0. So that's going to be negative 0.40. Back down again, the value I want from my table is this one right here, 0.3446. Okay, so that's the value that I want. And coming back in here, okay, and then coming back into my question here, so we just found 0.3446 from our table. We would subtract from 1, and there's our answer. All right, now we can get Minitab to do this in a flash. Let me go to Minitab here for a second. Hang on now while I get this straightened up. Ooh. All right, I'm going to the Graph tab, Probability Distribution Plot. This will show me area under the curve, View Probability, say OK. If I don't change anything, Minitab's going to use the standard normal distribution. So, hang on now, let me do this 2 ways. I could just leave it like this. This is the standard normal distribution, in which case I'm going to give it a z-score. So, I'm going to give it a z. I know it calls it x, but it means z in this case. I know the z-score was negative 0.4, and I wanted the area to the right of the 0.4. And there's my answer, which is slightly different than what I got from tables. Minitab is more correct because tables do rounding. Or the other thing I could have done here, rather than even bother with the z-score, I could tell Minitab what distribution I'm dealing with. Yes, it's a normal. It's got a mean of 6.2 and a standard deviation of 0.5. I go to shaded area. I want it to know what's the probability or what's the area to the right of an x value of 6.0. Make sure right tail is turned on, say OK, and there it is again. So I could have my plot done from the perspective of the z-score, where the mean is 0 and standard deviation is 1, or from the point of view of the actual distribution of earthquakes. All right, I'm going to do up a couple more videos to show you other parts of this question.